In this video, let me show you how to do the arc simulation. Okay, so it says drag the height of the launcher down so it's launching from an elevation of 0 meters. So don't worry that it's down in a hole. It is kind of annoying though. You can't set the barrel less than 25 degrees. Okay. Note that it really launches from the hinge sign, so don't worry that the barrel is higher than 0 meters. Set the initial speed to 15 meters per second and the angle to 30 degrees. All right, so 15, wangy. There we go. Let's set this to 30 degrees. There we go. Whoa, come on. There we go. 30 degrees. And fire the cannon. All right, that's easy. Are you ready for this? All right. Don't erase the track. Now set the barrel to 60 degrees and fire. Remember, 30 and 60 are complementary angles, right? These are angles that add up to 90. So let's do 60 degrees. Come on, baby. And this is, right? The sine of twice 30 and the sine of twice 60 are the same thing. Okay, so this has the same range. And you see this in American football, right? You see the low trajectories. That's what they use for forward passes. They have the same range as a high trajectory, right? But there is a difference, right? This one gets there later. The high trajectory gets there later. The low one gets there more quickly, right? All right. And then it says, try the same thing for 40 and 50 degrees, right? Go ahead and do it. I don't want to spoil it for you, right? But 40 degrees, right? And then do 50 degrees. And it's kind of cool. They land in the same place. So angle complements have the same range, right? So I just wanted you to try that. And then it says, drag the barrel up to a jaunty angle, select some velocity, but don't fire the cannon just yet. All right, let's see. Let's try, I'm going to try 18 meters per second, right? I'm going to erase this. I'm going to do a jaunty angle. I feel like 57 is pretty jaunty, right? Okay. And then what I want to see is I want to see you use the range equation to solve for where it's going to land, okay? So that looks like this. The range is v squared, that's just our launch speed, over g, sine of twice the angle. All right, so let's look at what our so it is 18 degrees and 18 meters per second, 57 degrees. See if I can remember that long enough, right? Okay, 18 meters per second and 57 degrees, 2 times. Let's see if I got it right. 18 meters per second, 57 degrees. I got that right. So type that into your calculator. I'm way too lazy to do that. Make sure you're in degrees, right? And then what you want to do is go out here and put that target where it's going to be, right? I'm just guessing that it's going to be about 30.2. Okay, and then you're going to fire the cannon. Baby, look at that, right? And what I want to see on your paper is I want to see the you typing this in, right? So that range is 30. All right. Hey, my battery's low. Okay. So 30.2 meters is what I get for that, right? And then the second thing I want you to do is I want you to do the opposite of that. I want you to solve for an angle, okay? So move the target farther or near, use the range equation, solve for the proper launch angle, okay? So let's move the target, and I want to shoot, come on, baby. No, won't let me do it. Okay. Hello. How about 21.8 meters, right? Let's make my launch speed. I'm going to change my launch speed. How about 13? Okay. We'll try 13. I don't know if 13 will hit it, but we'll try. Actually, I can check. 13 squared divided by 9.81. That's not going to hit it. Okay, so let's try 15. I'll try 15. 15 squared. Yeah, that can hit it. That can hit it. All right, all right, all right. All right, so, but you know what? I think I want to try a higher speed. Let's try 22. I'll try 20. Okay, I want to hit 21.8 meters, and I'm launching at 20 meters per second, okay? So remember that the range equation, if you solve it for the angle, right, that's going to be g times the range, the inverse sine of g times the range over v squared, right? And if g times the range is bigger than v squared, you're going to get a domain or a domain error on this thing, okay? So our angle is going to be 9.81, and what is our range? Our range is 21.8, right? Right, and it's going to be the inverse sine of that, right? Okay, all that divided by v squared. So what's our v? Our v is 20, right? All right, so I'm going to do that. I'm going to go inverse sine of 9.81 times 21.8 divided by 20 squared. And then this whole thing divided by 2, right? I get 16.16 degrees. Right? And this is going to happen to you, right? And then the problem is, of course, you try to set it for 16 degrees and you can't do it, right? It's like, rinky dinky inky, whoa, it won't go below 25. And you're like, dang it, dang this simulation, right? But remember that if 16.16 degrees works, then 90 minus 16.16 degrees works, right? So I'm just going to go 90 minus my answer. And I get 73.8 degrees, which is about 74 degrees. I don't think I can do a fraction of a degree, right? About 74 degrees, so let's try 74 degrees. All right, are we ready for this? Oh, it's off the screen. Baby, I got 3 stars anyway. Okay, that's what you need to do. So that's the arc thing. Now, stay tuned. Here's the question, right? You want the extra credit. Of course you want the extra credit, right? Okay, so for the extra credit, what you're going to do, and you're going to do something different from somebody else, is you're going to do this thing, pick some angle like that, right? Okay, so pick a height, pick an angle. And without shooting it, I want you to predict where it's going to land. Now, I'll give you a clue about this, okay? I'll give you a clue about this. You're just going to do a HV. There's no range equation. It doesn't work for this. SUVAT, right? Okay. So now let's take a look at this. Our vertical change in height is 7 meters. Okay, so this is down 7. The initial velocity is, well, I can figure that out, right? I've got the launch speed is 20, and the angle is 44 degrees, right? So I can figure out those angles, right? So this is 44 degrees. This is 20 meters per second. So I can find the x and the y, right? So you can find this guy and this guy using trigonometry, yeah? Okay. You know that this is negative 9.81, and then this is the tricky one to solve for the time, okay? It's either quadratic, or you have to do v squared is u squared plus 2as. You have to choose the negative answer, because that could be either negative or positive, and then use v as u plus at, right? Get the time, pull the time across, right? And then you know these guys, right? And you can figure out where it's going to land. Once you figure out where it's going to land, once you figure out where it's going to land, you're going to put the target there, right? Put the target there, fire the button. Hello. Oh, come on, I can't even shoot. There we go. Fire. Oh, hey, wait, I'm way off, right? Okay. Fire that thing, and it's going to land there. Now, if you need to zoom out, you can zoom out here. That's this thing. So if you need more space, you can do that. Okay. Anyway, happy hunting. That's how to do the arc part of this.